Hi everyone, thanks for attending my talk. Today I will present a paper called HCL Hybrid Contrastive Learning for Graph-Based Recommendation. So to summarize the contribution of this work, we first identify the limitation of existing contrastive learning methods for recommendation and propose HCL. Second, we generalize a permutational approach that performs hybrid contrastive learning across multiple views, which are generated to convey, communicate, and noisy information with respect to node embeddings and topology. The last extensive experiments show the superiority of HCL regarding to the model generalization and the robustness over the state-of-the-art baselines on two public and one internal dataset. ijcnn is a very strong graph collaborative filtering baseline for recommendation that captures the high-order connectivity from the user item bipartite graph, and the model is trained in a supervised learning paradigm. It is applied on the user item bipartite graph to learn user and item representations by aggregating the representation of its direct neighbors and with the defined graph convolutional operations. And finally, the Bayesian personalized ranking is used as a final loss. So based on that, we propose our HCL model extended from the ijcn. The supervised learning part is a typical ijcn model, and the gray area is the HCL proposed model. It basically contains the three components, including the bipartite graph augmentation operations, the graph multi-views, and the supervised CL and unsupervised CL loss. In detail, first we propose novel bipartite graph augmentation strategies by taking node embeddings and topology, including consideration to generate different incomplete and noisy views for the input user item graph. And the proposed hybrid contrast learning performs unsupervised and supervised contrast learning on homogeneous node and observed user item interactions, respectively. And we finally conduct the hybrid contrastive learning among multiple views permutationally. And first of all, we propose 4 bipartite graph augmentation strategies to generate different graph views, including the node embedding dropout, edge dropout, edge moving, and connecting similar homogeneous nodes. And for the hybrid contrast learning part, we define unsupervised contrast learning by put together the different views of the same node and put apart those of different nodes. For the supervised contrast learning, we propose to encourage the consistency of the embedding of the users and the interacted items by computing supervised contrast learning loss given observed user item interactions. We maximize agreement between user representation and its item representation generated from different views. For the multi-view permutation, the total multi-view HCL loss is the sum on the HCL loss terms computed on every pair of graph views permutationally, and each HCL loss term is the summation of unsupervised contrastive learning loss on user and item nodes and supervised contrastive learning loss as well. So the formula is shown below. And we train the model in a multitask learning fashion with a final loss. Let's take a look at the experiment. We adopt 2 widely used public datasets, including the Yelp and Amazon Book, and 1 internal Alexa recipe dataset to evaluate the model performance across the experiments. So for the baseline, we mainly adopt 3 categories of models as baselines for performance comparison. And the experiment results we showed here. First, we can see the model performance comparison on public data sets. So among all the baselines and our HCL model applied on 2 multi-views and 3 multi-views, K is the number of the views we created for the graph. And we can see that with when K equals 3, it generates the best results on the 2 data sets for all the evaluation metrics, including the precision, recall, hit rate, and NDCG, and the performance boost is significant. For the internal recipe dataset, we also compare the results among all the baselines, and similarly, the HCL with k equals 3 has the best results. And we also do an ablation study to see whether all parts of our model are all useful or not. If we remove each part, will cause a degradation of the model performance. And SGL part gives us the huge degradation, which means that SGL is the most important part for the model proposal. We also tune the parameters to see the effectiveness of the probability for bipartite graph augmentation. And we can also check the time for the training models for epoch, because we want to explore whether the HCL model is a light model or a very heavy model. We also do some other supplementary studies. For example, we compare the model performance with noisy ratios. And the bar represents the results in terms of recall and NDCG respectively. And in the end, we also visualize a user and item embeddings led by SGL and the proposed HCL. So in the end, in this paper, we propose a novel framework named HCL with 3 contributions to while exploit contrast learning for graph-based recommendation. And in the future, we aim to improve the model further by exploring negative sampling methods and involving curriculum learning that gradually incorporates more difficult negative samples. That's all. Thanks.